Cruising to cosmos.
Welcome to Cruising the Cosmos. I am Joshua Laughlin.
And I'm Jason.
This is our premiere episode. Are you excited?
I'm pretty excited. How about you?
I am excited. So we asked everybody, and they said the same thing. They want the basics. So today we're going to talk about binoculars and telescopes. Your vehicle for cruising the cosmos. Jason, what do you have there?
Well, I got a set of pretty basic binoculars here. These are just some regular 10 by 50s. Basically what that means is 10 is going to be your multiplication on it, so it's going to be able to see 10 times further than what your naked eye would be able to see. 50 is going to be your aperture. Basically this piece right here is a 50 millimeter lens. Whenever it comes to astronomy, you want to get as big an aperture as you can without it being too heavy. Whenever you get a little bit bigger than 50 millimeters, you start going into the 70s and up, and you start getting a little shaky. I don't know where else to go with that.
Well, I know the first time we saw Andromeda, we saw it through a pair of binoculars.
Yeah.
And it goes to show you that, there's an old saying, and that's size matters. Bigger is better. And that's true because the more light you can get in, the better the quality of the picture. But of course, if your optics aren't good, if the mirror or whatever type of optics you're using isn't up to snuff, it's not going to be worth anything, no matter how big it is. And so something as small as binoculars can even take in some really good images.
Absolutely.
And what's nice is, for instance, you're going to need, tripods, because I know when we tried looking at Venus the other night, our hands were very shaky. Everything was very shaky, and you'd be surprised of how shaky you are. So tripods. And what was nice is we were able to experience one with a parallelogram.
Yes.
And what's nice about that is no matter how tall someone is or how short they are, they can raise it up and they can lower it and not change what it's looking at. So it's really great for when you're at a star party.
I guess some of the couple things you want to keep an eye on if you are going to be looking at binoculars. You want to stay away from the kinds that you can adjust here for your zoom. You want to make sure that what you get is fully multi-coated, and that will be an anti-reflection coating, which will definitely help your image quality out. Other than that, always make sure you try before you buy. Make sure it's not too heavy. And that's pretty much it for your binoculars. Just remember, always keep your objective as big as possible without it being too heavy.
I know with binoculars, it's nice to have them, even if you're not going to use them primarily for stargazing, it's good to have them to kind of scope the sky out, kind of see what's out there. So don't think you don't need them just because you have another telescope. You'd be surprised what you can do with them.
Absolutely.
Now, another popular telescope you'll see at star parties are the refractors. And that'd be this one right here. And we have another picture. And this is a picture courtesy of Kelly Taylor. And that's his refractor. Refractors are really nice because they don't change the way the image is. It's going to be straight up just like you're looking through a pair of binoculars. They have great resolution, and they're not overly large, but they can get fairly large depending on the size. I know some downfalls are going to be the price.
Definitely the price.
What was the price that you were looking at for that 6-inch?
Just a little 6-inch, which is kind of, I guess, your basic. You'd be looking at right at about $1,000, even up a little bit higher than that for just a regular 6-inch. And that is not including a mount.
So you got to be careful. And though the image is great, don't get us wrong, the image is great. It's got some good resolution, great details, good for planets. Really great for planets, and you can get some good deep sky with it. Something you'd also want to keep in mind, though, is a UV filter. When you're taking images or taking pictures or looking through it even, you're going to get some purple glows around stars and things like that, and you're going to want a good UV blocker.
In what year was the first practical refracting telescope invented? Was it A, 1885, B, 1908, C, 1608, or D, 1733? Your answer later in the show.
So Jason, we just talked about the binoculars and the refractors. What do you have right there?
Well, this is a Newtonian reflector. This is actually my own personal telescope. These things are very cheap, very inexpensive. They actually give you a pretty good design. The way these work is a little bit different than that refractor over there with how the light enters. Josh, you have a picture of how that light enters?
Of course I got a picture. It's this. This here is the picture of how the light works.
All right. These are basic, very basic designs. They're probably one of the first and easiest designs to make. Like I said before, the good thing about these is they're cheap. They can come from a size. This is just a little 4.5 inch. They can go in sizes a little bit smaller than this, or they can go very, very big. They can get big in what they call a Dobsonian telescope. We can see them all the way up to 12 inch, which is really common now, all the way up to 16s, and if you got the money, well above that.
That is very true, and that is what's great about, for instance, Dobsonians. I personally have one. I spend around $800, and it's a 12-inch Dobsonian. So that goes to show you, the difference between a Dobsonian and a refractor in the price ranges. Some of the cons, though, is it flips the image. It's going to be inverted.
Absolutely. And with a Dobsonian, you're going to be looking at a bigger overall package than you would a refractor. A 12-inch Dob is going to be, I'd say, probably a little over 5 feet tall, and then the eyepiece is going to be just like with this one here, at the edge. It's not going to be at the end, it's going to be at the edge, which means if you get something over a 16, you might have to carry a stool with you.
That is very true, and they become very cumbersome. They're not light. If you get a solid tube metal, it's gonna be pretty heavy. You're definitely gonna want straps. Absolutely. You're
Probably going to end up seeing more Dobsonians at star parties than you will anything else, just because of the aperture that you can get. Like you said, bigger is always better. I guess some of the ways they combat the heaviness of it is that you can have a collapsible Dob or you can have a truss tube Dob. All those break down pretty easy and allow for very big mirrors.
That is true, and if you can get yourself a truss tube Dob, I want to say I've seen them run for about $1,000.
For a 12-inch.
For a 12-inch, mind you, that's a 12-inch. And 12-inch is really where I feel, I don't know about you, but I feel that's where you should start, is with a 12.
Very good sweet spot.
It's kind of the, you're going to get a good image. You're not going to get, of course, the best fine image, but you're not going to get a very poor either. So you're going to get a really good solid image with a 12. And that's why I personally went with it. Mm-hmm.
A curved primary mirror is the reflector telescope's basic optical element that creates an image at the focal plane. The distance from the mirror to the focal plane is called the focal length.
So, Jason, some of the things that I've noticed, and personally, I lack one. It did not come with my telescope. So, I highly suggest, if you get a telescope, make sure it has it. If not, buy one. And that's a red dot finder to find the stars. A good option for Dobbs is going to be a Telrad. And I know something else would be nice is laser pointers.
Absolutely. You definitely need a laser pointer if you're going to go out in astronomy. One of the things that we talked about in our first video was to make sure that it is red or green For the laser point, it'd probably be green.
Green's nice. I do not like the purples though. No, too bright. Too bright. As far as lights though, stick with red.
Stick with the red for your lights.
A dim red, not no bright LED red. A very dim red. You do not want to mess up your dark vision.
Definitely not.
Gotta get it all for night vision.
The Newtonian telescope was the first successful reflecting telescope completed by Isaac Newton in 1668. It is one of the simplest and least expensive designs and is popular with amateur telescope makers as a home build project.
So we've talked about a few different telescopes, but there's one more that you might actually see at a star party, and that's the SCT, also known as a Schmidt-Cassegrain telescope. What's nice about it is it kind of fills that gap between the refractors, very expensive, great quality, and your reflectors, your Dobsonians, which are, again, really great quality, not as good as refractor, but they're also very, very cheaper. Much cheaper.
Much cheaper.
Much cheaper. So, what's great about them is they're compact.
They are.
They're very compact. I believe we can get a picture.
We can.
Like this one. So, they're very small. Fit them in the back of cars, back seat, front seat. I mean, they're easy to port. They're very portable. And good price. We know you can get one for a little over $1,000. It's an 8-inch.
Yep.
Basic mount, though. Basic mount.
Basic.
And they're good for astrophotography. But if you're going to do astrophotography, make sure you get a good mount. You're going to want one that can track really well. So they can get up in price. You're looking at around $2-3 grand.
Yeah, I think we saw some 12 inches for a little over 3. But I'd say for a 12-inch SCT, something that'll give you a quality of a refractor with the aperture of a Dob or reflector, you can't really, I guess, go wrong with a mount like that. I mean, it's not going to look like a traditional telescope because it's nice and stubby, but it doesn't look something like that or like that where you look at it and be like, yeah, that's a telescope. It almost, I don't know, to me it just reminds me of a nice big stubby camera.
Yeah. The light waves move a little bit different, and they do fold back in on themselves. This diagram right here shows how the light comes in and it hits the secondary mirrors and they come back on you. So you do kind of have them like a reflector. They're also kind of like a refractor. So it's really nice. They're portable and they're kind of that mid-range price. There are a few differences between the three, and the main thing is how you collimate them. A refractor, for instance, you take it apart, you're going to have to take a few screws out, and you collimate it. You still need a laser, but once you collimate it, you're not likely going to have to do it again. It's going to stay that way. Unless you really are brutal to your telescope, you're not likely going to have to do it again. However, the reflectors, and again, Dobsonians, they're going to have to do it quite often. And if you don't have good springs, you're going to do it every single time you set up. Now, I know the SCTs, they have a very specific way. They have a special grid you have to use. So it's a really different beast altogether. So each one has a different way of going about it.
With regards to a telescope, collimating is the process of aligning the optics of the telescope so the light exits the eyepiece. With a poor alignment, you get a poor image.
So we've discussed the primary telescopes you're going to see at a star party. The thing to keep in mind is buy what you can afford. The bigger you can get, the better. But if you can't spend a lot of money, the Dobsonians are going to do a great job. They're the best I think you can get for your money. If you got a lot of money to dish out, do it. The thing with astronomy, though, is if you actually want to turn it into a hobby, It's a lifelong hobby, and it's a money sink. You're going to be spending lots of money. You got your eyepieces. You got a lot of different filters you can get, mounts, telescopes, and it really never ends. You got your people that not really that much into it, just they like to look at things, so they're not going to spend as much. And that's just something to keep in mind. Exactly what do you want to do with your telescope? My advice is find your local astronomical society. We'll provide a link that's provided from the Astronomical League, and it'll show you who's in your area. Contact them, join a star party, try out the different telescopes, and see for yourself what you want.
Don't trust all the guys in the forums. We see a lot of people who we hear from a lot of our local refractor guys to where people say the refractors are no good. I've looked through a pretty nice one myself, and you know the image didn't make me mad. But a lot of people talk on the refractors. Some people will talk on the reflectors. Don't always trust what you read. Always do your research. There's a lot of good guys out there in the community. Your local astronomy club is good. There's always there's usually some retailers around in your local bigger cities. You can definitely trust in their experience most of the time.
That's very true.
Your answer to the trivia question is C, 1608.
So, science in the news. First off, we found a blue planet. You heard me right, a blue planet.
A blue planet.
A blue planet. So, 63 light years away is HD 189733. Long name, I know. It's an orange dwarf. It's a loose binary star system with a red dwarf circling it. Also, around that red dwarf, around the orange dwarf is the planet. It's 3 miles away from the star. 3 miles.
That's pretty intense.
So it gets so hot because of that being so close. It gets around 1,800 degrees Fahrenheit.
Yeah.
It's got high winds even on the dark side. Now, Neptune is also blue.
It is.
But it's blue because the methane gases are absorbing the red light.
Oh, why is this one blue?
This one's blue because the silicates is in the atmosphere reflecting blue light.
Okay. Well, how do we figure that out?
A spectrograph. We have telescopes in space, and they actually can take in the light and the prisms, and you at home can do this as well. It's a spectroscopy. And it's very nifty. You can look at stars, planets, whatever you want, and it will take the light, break it up into prisms, and you can see what it's made of. And what they found is it was reflecting blue light. Anytime it was gone out of its image, they would notice this huge drop. And we could tell that this planet is blue.
Nice.
Very nice. Unfortunately, it's nothing like the Earth, so we're still looking, but we haven't found one yet. Also in the news, Andromeda and our galaxy, the Milky Way. We all have an understanding that they're going to collide. A new theory states that we have already collided. Now, what's nifty about this theory is if it's correct, it's going to change some things, because the only way for the two galaxies to have collided and not come together is if there's no dark matter halo that surrounds the galaxies. Dark matter being the substance that attracts everything. So that's going to be some really groundbreaking things. We don't know for sure yet, but it's something definitely worth looking into.
That is. That's definitely one of the ones that I'm very interested in hearing the results of.
Lastly, what we're going to talk about today is a new article that was released on the 10th. That's July 10th. And it states that around our solar system is a tail.
A tail?
A tail. We don't know the exact size yet, the exact length of this tail. They're going to be doing the research. They're going to get back to us as soon as they can. Hopefully, we won't be waiting too long.
Hopefully not.
A cross-section of the tail resembles a four-leaf clover. Two clumps moving really fast, two clumps moving really slow. We've always suspected that there was a tail, but now we have concrete proof. There is a tail. We're traveling through the interstellar medium, and we have a tail.
Leaving our mark.
Leaving our mark. Well, this is Cruising the Cosmos. I hope you enjoyed our premiere episode. Anything else you'd like to add?
That's about it, actually.
Jason, if you could please tell me, pull up our schedule, please.
Enhance.
Pull up schedule.
Will you leave that in there? What are we looking for?
The 27th. Thank you, Jason, for all your assistance. We will see y'all again on the 27th. Again, this is Cruising the Cosmos. Thank you for joining us.
Kirk out.